Assalamualaikum warahmatullahi wabarakatuh. Hi, good morning to all my students. Okay, so in this video, we are going to look into the topic 2 of differential equation, and I'm now focusing on tutorial questions. Please refer to your tutorial books, and we look into both of the subtopic of separable variables and integrating factor. Solving the differential equation using separable variables and integrating factor. Okay, so I'm not going to solve or show the solution for every single question here. I'm going to choose, might be one or two for each. Let's say if I choose question A and question D. Find the general solution. General solution means that the function of the answers will end up with a constant of C. Okay, so for example, for question number 2a, we got dy dx equal to 6x squared and y. Okay, so let's say this is a sign of equal. So on the left side, we try to come up with this is a function of fy dy, and here is an fx dx. We separate the variable with this we call respect to the variable itself, and x and dx here. Okay, so now this is house of y. Okay, I define this on left side as a house of y, and on the right side or the other side is a house of x. So in here we divide or multiply with 1 over y and also 1 over y. So come up with 1 over y dy, then 6x squared dx. So before we integrate left and right, let's double check. Do you find any x left here? No, right? It's 1 over y dy. And you find any y left here? No. That's all x. X and x with constant of 6x squared is all okay. So now it's time for us to integrate left and right. So integral of 1 over y, natural log of y equal to 6 integral of x squared, come up with x cubed divided by 3 plus c. Okay, so 6 divided by 3 equal to 2x cubed plus c. To eliminate the sign of ln here, we come up with a constant of Euler's constant of e. So is something like this one here, natural log of y, come up with constant of e here. So then y equal to e power of 2x cubed plus c. Okay, look at this one here now. Okay, look at this. Is something what we call, please remember what we learned in topic 1 of semester 1. What we call chapter topic 1 of the semester 1 then, with a to the power of n plus n equal to a to the power of n s multiplied with a to the power of n. For this one here now, it is y equal to e power of 2x cubed multiplied with e to the power of c. Okay, for this one here now, e is a constant and c is also a constant. It's just like 2 to the power of 3. Two constant numbers and power of any constant numbers here. We can simplify it as a one constant, which is 8. So for this one here, let's make this one as an a e power of 2x cubed, where a equal to e to the power of c. Okay, so that is the first one. And now the second part, the second question then here, which is d. I chose d as now. 2y dy dx minus xy squared equal to an x. Okay. Which I think that we bring this negative x y squared to the other side, to y dy dx equal to negative x y squared, then here become positive x y squared plus with an x, which is also equal to factorize x with an x, and we got y squared plus 1. So 2y dy dx, okay, again 2y dy dx equal to x y squared plus 1. Okay, so let's separate the variables y on the left side and x on the other side. So divide by y squared plus 1 on right side, and also here come up with 2y divided by y squared plus 1. Okay, 2y divided by y squared plus 1 dy equal to x. Okay, there's no x here except for this one, x dx. Okay, so it's time for us to integrate left and right for both of this. Okay, now let's focus on this left side here. Integral of 2y divided by y squared plus 1. So, which I think that we're going to use the, using substitution method. Okay, substitution method, which is u equal to y squared plus 1. So then du equal to 2y dy. Okay. 2y dy. Okay. And just imagine that this is 1 over. So integral, it is actually an integral of 1 over y squared plus 1 multiplied with 2y dy. So, integral of 1 over u, 2y dy, 2y dy, 2y dy equal to du. Okay, integral of x dx come up with x squared over 2 plus c. So this one here come up with natural log of u equal to x squared over 2 plus c, and again come up with constant of e and e here, then u equal to, okay, don't forget that we replace u, substitute with u with y squared plus 1, so come up with e, cancel these two, and also e here, so then u equal to y squared plus 1 equal to a e power of x squared over 2, where a equal to e to the power of c, just like the case of this one here now. Okay, and then this one is y. We wanted the final answer in the form of y equal to fx. Okay, we try to form into y equal to fx, so then y squared equal to a e power of x squared divided by 2 minus 1, and finally y equal to square root of a e power of x squared divided by 2 minus 1. There you go. Okay, so that's the solution for question number 2. For this one, which I think that I'm going to choose a particular solution of the equation using separation of variables method. And at this time now, look at this one here. Okay, let's see if I choose a question of B. It means that here, well, x equal to 2 and y equal to 3. Okay, so x dy dx equal to xy plus y. Now, factorize between these two, y with x plus 1. So it's time for us now to separate the variables x dy dx. separate the variables, so divide by y, right and left. So it is 1 over y dy. Bring x to the side, x plus 1 divide by x dx. Okay, so which is 1 over y dy equal to, okay, for the whole of this, it's just like a plus b divided by c equal to a divided by c plus b divided by c. Okay, so look at this one here now. It is x over x plus 1 over x dx, which is 1 plus 1 over x dx. Okay, so then continue here with 1 over y dy equal to 1 plus 1 over x dx. So you can, do you find any x left here? No. Y? No. Okay, so we integrate, starting integral left and right here, we come up with natural log of y equal to integral of x1 respect to the x plus integral of 1 over x natural log of x plus c. So again, the constant of e here and here, then y equal to ex plus natural log of x plus with c. Again, using the rules of index, a power of n plus n equal to a to the power of n times a to the power of n. So here, e x times e to the power of natural log of x times e to the power of c. And this one here come up with an x. E x and e power of c equal to n a. Okay, don't forget that we he given to us the value of x and y. Actually, that you may substitute the value of y and x at this point here. But it's okay, we substitute in here now. So then, when x equal to 2, y equal to 3, y 3 equal to a, x equal to 2, and e 2. Okay, so then we like to find out what is the value of a here, where a equal to 2e squared, which divide by, okay, 3 divided by everything here, which is 3 divided by 2e squared. Okay, so it means that here substitute the value of a here. So then y equal to 3 divided by 2e squared, then x e to the power of x. Plus, I think that I found my mistake here. It's not a mistake of substitute the value, it's not a substitute, we call the mistake of the techniques, but I mistakenly substitute the value of x and y again, sorry. Look at this one here. This means that the value of x equal to 3, y equal to 2, but I make a mistake here by assuming that x equal to 2, y equal to 3. So I'm sorry for this one here. Okay, it's not the wrong method or wrong working solution, but I make a mistake by substituting the value of x and y. So in this case, x equal to 3, y equal to 2. Sorry again. Okay. Okay, so when x equal to 3, y equal to 2, and sub, okay, y here, so y equal to 2, 2 equal to a, x equal to 3 times 3, and e power of 3. Okay, so a equal to, a is 2 divided by everything here, which is 2 divided by 3e power of 3. Okay, and this a, this value of a, that is equal to 1, they're going to use substitute in this point here now, a. So y equal to a 2 divided by 3e cubed multiplied with x and e to the power of x. Okay, so we continue with question number 16. So question 5 just now, I let all of you to, continue, try by yourself. So class, find the integration. Find the following differential equation by using integrating factor. Okay, before we continue with the questions here, this is the general equation of the equation here, px times y equal to qx. Okay. This is the equation that we must get in this form. Okay, for every single question of A, B, C, and D, make sure that we get into this form first before we starting to labeling the Px and Qx. Make sure that the coefficient of dy dx here equal to 1. Okay, so for example here, I choose question number A and D and C here. Okay, so dy dx plus 2xy equal to an x. Okay, so compare the whole equation of A with this one here, where the coefficient of dy dx equal to 1. Coefficient of dy dx here equal to 1. Okay, 2xy, bx multiplied with y, and also qx. So this question is already in this form. So now we list down the px equal to 2x and qx equal to an x. Okay, so we are going to find the integrating factor. Some books they use the term of ix, and some books they use the term of vx, integrating factor v. It's all up to you then. Okay, it's either v or x, is just a symbol. As long as we know that, we are trying to find the integrating factor of that. So I use the vx, I mostly use the vx here, which is e to the power of integral of px dx. So px here now, according to this, is a 2x, so integral of 2x dx. So then, integral of 2x dx, integral of 2x dx equal to 2x squared divided by 2, am I right? So 2 divided by 2 is x squared here, e to the power of x squared. So this vx, or integrating factor, this we are going to multiply with the whole of this. Okay, so vx multiplied with dy dx plus vx times 2xy equal to vx multiplied with qx, which is x here. Okay, and then from here, if we integrate everything here respect to the x, integrate this respect to the x, okay, the whole terms in this bracket is actually the result of what we call derivative of Vx multiplied with y. Okay, integral of Vx, which is Ex squared times dy dx plus with Ex squared multiplied with 2xy dx equal to integral of Ex squared multiplied with x dx. Okay, why that I think that this is an expansion of this? Let's say if we substitute this one with Ex squared. Okay, now the derivative of Ex squared multiplied with y, differentiate this first. Ex squared, it gives you 2x e power of x squared times y. You still remember this? Differentiate this first, it gives you 2x e power of x squared multiplied with y plus with Ex squared and derivative of y, differentiate of y respect to the x, dy dx. Okay, let's compare everything here with this one. Ex squared dy dx. We get here, right? Ex squared dy dx. Ex squared times 2xy. 2xy multiplied with e power of x squared. It's all here. Agree? So it means that here, this is integral of the dx of Ex squared times y dx equal to integral of Ex squared and x dx. So the cancelling between the derivative and integration, this gives us what we call the contradict between the derivative of Ex squared y with respect to the x, and also integral of, okay, between derivative and integral cancelling each other, then it gives us Ex squared times y equal to integral of Ex squared times x dx. Okay, so we are going to solve the one on the right side because this one is cancelling between the derivative, then differentiation and integration. So it becomes neutral now. So for this one here now, let u equal to x squared, so then du equal to 2x dx. What we have here right now is x dx, and what we have here right now is 2x dx, so make this one as du over 2 equal to an x dx. So Ex squared times y equal to integral of eu and x dx equal to du over 2. Okay, now what about this? Okay, it is 1 over 2 integral of eu du is eu plus c, or 1 over 2 e and u equal to x squared plus c, then y. This is Ex squared times y. So we want the equation in the form of y equal to fx. So divide by Ex squared, y equal to 1 over 2 Ex squared divide by Ex squared. We divide by this one here, left and right, plus with c, and then divide by Ex squared. Clear these two, and equal to 1 over 2. Okay, clear this with itself equal to half, plus with c e power of, okay, there's not much space there. This is 1 over 2 plus with c e power of negative x squared. There you go. Okay, I promise to all of you, let me show this one c. Well, we got no enough space for here. Okay, you copy all this first because this in the video, so you may call pause, rewind, forward, and okay, as you know what I'm trying to say to all of you. Because the next slide, I already prepared for the question 7 here. For this one, I clear everything first, and then we discuss on question of C. Okay, well then, I'm sorry if I go with this kind of presentation, make all of you tired or confused. Okay, sorry then. Okay, we continue with the question of 16C, number 6C here. 6C, where 1 plus x dy dx plus y equal to an x. Okay, this is 1 plus x. Okay, we compare this with this form, where the coefficient of dy dx equal to 1, but for this one is 1 over x, meaning we are going to divide by 1 over x, okay, to every single term that we have here, here, and here. And you come out with dy dx plus 1 over 1 plus x multiplied with y equal to x divided by 1 plus x. Okay, so here the coefficient of dy dx equal to 1 here now. Okay, so already in this form, and our px equal to 1 divided by 1 plus x, and qx equal to x divided by 1 plus x. And vx equal to e to the power of integral of 1 over 1 plus x dx. Okay, integral of 1 over 1 plus x dx. Okay, derivative of 1 over 1 plus x dx equal to natural log of 1 plus x plus c. You remember this? Okay, so it's making that is come up with e power of natural log of 1 plus x. Cancel between these two, then you come out with e and ln cancelling each other, so you come out with 1 plus x. Okay, so now this v, integrating factor of 1 plus x here now, vx. This vx, are we going to multiply with this equation? No. Okay, because the equation of the question here is not in this form, exactly in this form. Okay, if not, then this is v, we are going to multiply with this equation. The equation that had been, we call adjustment, we call run through of adjustment, that we call change, make some adjustment, and this equation here right now exactly in this form of 1 dy dx, 1 dy dx. So then vx multiplied with dy dx plus with vx multiplied with px times y equal to vx ux. Okay, and here is 1 plus x multiplied with dy dx plus with 1 plus x multiplied with p is 1 over 1 plus x, and then y equal to v is 1 plus x qx, q equal to n. Okay, wait a minute. Px is 1 over x, y, and also qx is here, not this one x. This is a qx here. Multiplied with x divided by 1 plus x. Okay, so integral of everything here respect to the x. Okay, actually these all are the result of derivative of 1 plus x multiplied with y. Okay, let's try. Derivative of 1 plus x equal to 1. Okay, derivative of 1 plus x equal to 1, and then y here. Next, 1 plus x here, and derivative of y respect to the x is dy dx. Okay, so we call derivative of 1 plus x multiplied with y. It gives you all this. So if we integrate we call integral the whole this, the integral, the derivative of all this, so the derivative and integrate cancelling each other. Finally, it gives you 1 plus x multiplied with y. So we integrate left and we integrate on the right side here now. And 1 plus x divided by 1 plus x. So actually we are talking about we integral of x dx. It gives you x squared divided by 2 plus c. Then y equal to x squared over 2 divided by this means that 1 over 1 plus x plus with c divided by 1 plus x. Okay, so it's something like this. There you go. Okay, question number 6. For this one here now, let's say if I choose question number B. Okay, so x squared dy dx plus 3xy equal to x squared plus 1. Then divide by x squared here, here, and here, dy dx plus, okay, plus 3xy divided by x squared equal to x squared plus 1 divided by x squared. Cut this and one of this one here, so dy dx plus 3 over x times y equal to x squared plus 1 divided by x squared. But before that, x squared plus 1 divided by x squared, which is x squared over x squared plus 1 over x squared, am I right? So x squared divided by x squared, 1 plus this one here, we assume that this is x power of negative 2. Okay. Okay, okay, never mind. We leave it on this first. Let's see what is our integrative factor that we get to get. So then, Vx equal to e power of integral of 3 over x dx. Integral of 1 over x dx, which is 3 natural log of x, am I right? So, e power of 3 natural log of x. Using the log rule brings 3 here, and e with ln cancel each other, come out with x cubed. Okay, so x cubed, are we going to multiply with this equation? No, because the coefficient of dy dx is not 1, it is x squared, so it's not it. We are going to multiply this here. Okay, so means that x cubed dy dx, x cubed times dy dx, and then this one here, okay, we can refer to this one, the simplest one here. Okay, x cubed dy dx plus with x cubed times 3 over x times y equal to x squared plus 1 divided by x cubed divided by x squared multiplied with x cubed. Okay, cut this one here, become 2, and here x. So then, as I mentioned before, actually the expansion of this is the derivative of v, which is x cubed multiplied with y. Okay, equal to, and this one here, x squared plus 1, x cubed divided by x squared, x. So derivative of x cubed times y, then you get this one here. So integral respect to the x, derivative, differentiate and integrate. So cancel each other. Integral this respect to the x. Okay, now if I take this one here now, okay, so x cubed times y equal to integral of x squared plus 1 times x dx. Expand this x squared times x times x squared, integral of x cubed, and then x times 1 equal to an x dx equal to x 4 divided by 4 plus with x squared over 2 plus c. And then divide by x cubed here, 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 and here. Do we need to, okay, class x cubed times y. Okay, let's take a look at this one here now. X equal to 1 when y equal to 1. So 1 cube is 1, and y also equal to 1. 1 power of 4 divided by 4 plus 1 square over 2 plus c. This is 1. So c equal to 1 minus 1 over 4 minus 1 over 2, which is 1. How can I say this? 1 minus 1 over 4, 1 over 1 minus 1 over 4, okay, 1 minus 1 over 4 minus 1 over 2. It is 1 over 4. Okay, everything here equal to 1 over 4. Okay. So now when c is 1 over 4, then refer back to this one here, x cubed y equal to x 4 over 4 plus x squared over 2 plus 1 over 4. Then y equal to divide by x cubed here, divide by x cubed, divide by x cubed, divide by x cubed. So x power of 4 divided by x power of 3, x over 4. X squared divided by x cubed, 1 over 2x plus 1 over 4x cubed. There you go. Okay, this one here now. Then the last final question for this video, where x dy dx minus 3y equal to an x 1 plus x cubed. Okay, again, this equation is not in general form of integrative factor because the coefficient of dy dx is not equal to 1. So we divide by x here, here, and here. So then dy dx minus 3 divided by x times y equal to x divided by x and 1 plus x cubed. Okay, so this exactly in the form of dy dx plus bx times y equal to qx. Okay, so the coefficient of dy dx equal to 1 here and also 1 here. So px equal to negative 3 over x. Qx equal to 1 plus x cubed. Then Vx equal to e to the power of integral of negative 3 over x dx. It is e power of negative 3 natural log of x. Bring this negative 3 above here using the logs rule, and e and natural log cancelling each other. It is x power of negative 3 or 1 over x cubed. Okay, so this Vx multiplied here. Okay, so 1 over x cubed dy dx plus 1 over x cubed. And here is my recall 1 over x cubed multiplied with this one here and negative 3 over x. Sorry. Okay, negative minus v 3 over x times y equal to 1 over x cubed. Qx equal to here 1 plus x cubed. Okay, so again integral everything here respect to the x and also integral everything here respect to the x. And this one you can give you Vx times y. Okay, it's actually that this is 1 over x cubed times y equal to integral of 1 over x cubed 1 plus x cubed dx. Okay, and this one 1 plus x cubed divided by x cubed is just like 1 divided by x cubed plus x cubed divided by x cubed, which is 1 over x cubed plus 1. Okay, integral of 1 over x cubed, integral of 1 over x cubed, or integral of x power of negative 3 plus 1. 1 over x cubed or x power of negative 3 plus 1. dx. So x power of negative 2 divided by negative 2 plus integral of 1 x plus c. Okay, now substitute. Don't forget we have a value of x here. X equal to 1, y equal to 1. Okay, so then substitute here 1 over x cubed times y, or 1 over 1 cubed times 1 equal to this is negative 1 over 2 x power of negative, or x squared. 1 over 1 divided by negative 1 over 2 x squared plus with an x plus c. So then negative 1 over 2 1 squared plus 1 plus c. This is 1. So then c equal to 1. Negative 1 over 2 being inside become positive, plus 1 over 2 minus 1. So c equal to 1 over 2. Okay. Now, 1 over x cubed times y equal to, here it is negative 1 over 2 x squared plus with an x, c is 1 over 2. Okay, substitute x cubed here, x cubed here, x cubed here, and x cubed here. Then y equal to x cubed divided by x squared, negative 1 over 2 x. X multiplied with x cubed, x to the power of 4 plus 1 over 2 x cubed. Okay, so these are few questions of the tutorial focusing on the separable variables and integrating factor, and we recall both of the cases when they given in general solution and when given to you the value of x and y to find the particular solution, something like this. So I do hope that it's helped you to continue with the rest of the question and also the PSPM question. That's all. Thank you very much. Next session, we're going to discuss or look at the question of application of differential equation. That's all. Assalamualaikum warahmatullahi wabarakatuh. Have a nice day.